Today I will be talking to you about the two special triangles in trigonometry. Now, these two triangles may not seem like anything special on the surface, but very soon you will realize that they are in fact the two most important triangles you will learn about. The first of these is rather simpler than the other. Picture a right isosceles triangle. Two of its sides are 1 unit each, while the other side is unspecified. The two even sides, as are the trait defining an isosceles triangle, form an angle of 90 degrees, making it also a right triangle. Now, first thing we need to figure out with this triangle is the length of the other side. This side is easily findable using the Pythagorean Theorem. If we know that the two other sides are 1 unit each, and this is a right triangle, we can add their squares together to find the squared value of the hypotenuse of the triangle. In this case, however, the value of 1 squared is still 1. Therefore, the squared value of the hypotenuse is 2, which means the value of the hypotenuse is the square root of 2. Now that we have these out of the way, you might be wondering, why is this triangle so special? Well, it contains a 90-degree angle and two 45-degree angles. This on its own isn't anything too shocking. However, it is used to remember important angles involving cosine and sine. Now, a 45-degree angle has the same cosine as it does sine. Now you see on here that the sine of a triangle is its opposite side divided by the hypotenuse. Sorry, the sine of an angle, not the sine of a triangle. The sine of an angle is the side opposite to the angle divided by the hypotenuse. Therefore, it is 1 divided by the square root of 2 for either of the 45-degree angles. Of course, we know that a 90-degree angle's sine is 1 because it's not really usable in this scenario since the opposite of it is in fact the hypotenuse, but that is off topic. The cosine value is the same because the 45-degree angle is on two sides. Therefore, no matter which angle you choose to place the cosine function on, its adjacent value will always be the same, 1. And the hypotenuse, of course, remains the same as the square root of 2. This goes for the sine as well, which makes the cosine value of 45 degrees 1 divided by a square root of 2, and the sine value of 45 degrees 1 divided by the square root of 2. This is the first of the two essential special triangles, and it is used to remember the cosine value of 45 degrees and the sine value of 45 degrees. Now the next triangle is an equilateral triangle, which means a triangle with all three sides having an identical length. And these three sides are all with value of 2 units. Now say we cut this triangle in half. This will give us a right triangle with one side that is 2 units long, one side that is 1 unit long, since the base of the triangle split in half would be equal to 1 unit, and a side of undefined length. First, we should find this side of undefined length. Now, since we know the hypotenuse, which would in this case be 2, and one of the two sides that would whose squares would add together to form the square of the hypotenuse, which is 1, we can find this other side by taking the square of the hypotenuse, which is 4, as the hypotenuse is 2, and reducing the square of the other side, which we have presented to us, which in this case is 1, which squared is also still 1, would give us 3. So we know that the other side that we are looking for here is the square root of 3. Now that we have this, we can calculate the angles, the cosine and sine values for the angles of 30 and 60 degrees. Well, wait a second, you might be thinking, where did these 30 and 60 degrees come from? Well, in an equilateral triangle, all angles are 60 degrees. However, since we've cut the triangle in half, one of its angles will be 90 degrees, since we have created a rectangular triangle, and the other will be 30 degrees, because it will be the 60-degree angle you see here cut in half, which is 30 degrees. Now, this allows us to find the cosine and sine values of 30 and 60 degrees respectively. So, say we take the cosine value of the 30 degrees on top here. That would be adjacent divided by hypotenuse. The adjacent to this value is the square root of 3. The hypotenuse is 2. Therefore, the cosine of 30 degrees is the square root of 3 divided by 2. Now let's take the sine of 30 degrees. The sine of 30 degrees takes the opposite, which is 1, and divides it by the hypotenuse, which is 2. But we can see here that if we take the cosine of 60 degrees, the adjacent value is the same as the opposite value of the sine of 30 degrees. Therefore, the sine of 30 degrees is equal to the cosine of 60 degrees. It applies the other way around too. The cosine of 60 degrees is equal to the sine of 30 degrees. So let's get this clear. The sine of 30 degrees and the cosine of 60 degrees are both 1 divided by 2. The sine of 60 degrees and the cosine of 30 degrees are both the square root of 3 divided by 2. You can probably tell this triangle is memorized for the memorization of the values I have just given you. Thank you for listening.